So we're going to start with the review, which was this one. So I'm just going to start off the top and not that one. Let's see. This one. Okay. Here, bring you here. And there we go. Okay. So this I don't need to care about. Also don't need to worry about. Is there anything specific here that you were worried about?
Not really.
Okay.
We kind of like briefly look at those. So.
All right, perfect. So here are like the operators. I think we went over a lot of them in the last exam. Here's like that chart that she gave, and here's the like PEMDAS, whatever. So if this is given, I don't think we need to cover this too much. Yeah, I think that's it. I'll just go through these and just name whatever they all are. So we have the both types of parentheses, the parentheses and the brackets, the increment, the decrement, the addition, the like subtraction, the not operator, the typecasting one, the and then the multiplication one. Then we have multiplication, division, and the what is it called? The remainder function. I forgot what it was called. Then the plus minus. Yeah, modulus function, and then we have the equality operators, and then these are the comparison ones, and these are also comparison ones, but you do these ones first, and or, and then this is going to be the if statement one. Then we got the assignment operators, which is the plus equal, and these all ones do the operation in front of the equal sign first, and then assign it to the variable on the left side, and then the comma. So we'll go back to this. This should be fine. I think these are all the things that are here. Went over the precedence chart, and so that's what all of them are. Conditional operator, there's that if statement one. And can you explain this one?
Yeah, so the assignment assigns the equality, checks if it's the same.
Perfect. Great job. We got these ones, and the switch statement is like a if tree, and then we have the loops. You should be able to switch between both of the loops because they're pretty easy to switch between. A for loop is in reality just a very specialized while loop. And then there's the do while loops, and then these two keywords, and then nested loops. So other than that, I think we're pretty good. So do you know what the error for this thing was? Any clue of what was wrong here? Was that a no, right?
Not that I can see so far. I'm still looking.
You're good. So this is the class is in C++, yeah?
Let's just see.
Just C. Okay. Sounds good. Let me pull up the compiler, and then we'll go here. So in the first example, have you thought about what's wrong?
Maybe counter plus equal to 2.
Which part? Yeah. What part about that?
I feel like it should just be like counter plus 2. I don't know actually.
Okay. So in the first example, I had done this example on the C++ compiler, so I'm going to move it over to the C compiler and see if that changes anything. Um, do, do, do. Mhm. Okay. So here, when we have the original whatever, let me see if I can do this. Yeah. And its counter is equal to 2, like this, right? Let me make sure everything else is the same. Yeah. Oh, sorry, this part is also. Then we run it. We have this little hiccup, and that is, I have no clue what we're on. Oh, okay. I guess that's broken. I'll just recode it. But basically, it's the integer wasn't declared here. So when you just put counters equal to 0, you need to say what type of variable it is. So when you divide it, it has to be int counter equals 2, right? Actually, I can just do this. Yeah. And then do. And another error that they'll put in the exam is that they'll, for this equality operator, they'll instead make it a single equal sign instead of a double equal sign. So it'll instead assign. And what is the issue with that usually?
It shouldn't assign it, right? It should just like increment it.
Yep. Let me see. This needs an.
Is it less than or equal to 100?
Yeah, and so it also needs the equal to get include 100. So that way it'll have 100 at the bottom. Because by having the 2 here, it does it. Say for example, I got rid of this and instead put this, it'll say that there wasn't a declaration of it. And so that wouldn't have worked. So yeah, that's that. Let me see if I can do the rest in the C compiler then. Because it should be this about the same. But maybe you don't need to do that in C? Yeah, okay, cool. So this guy needs to be declared here, and then it'll work. Sound good?
Yeah, so there's just the 2 errors.
Yeah, there were the 2 errors where there was the declaration here and the logic. The syntax error was the int not being included here, and then the logic error was not including the equal sign here if you wanted to have 100 at the bottom.
Okay.
Okay, and then we have this one, and this is basically about the same thing. What do you think the issue is here, though? Sneak peek, right?
I think the pre-incrementing,
The where?
the plus x.
Oh, okay.
I
So
think.
actually, this part is fine.
Oh really?
Yeah. So what you would see if you ran this, right? What do you think is gonna happen? Actually, let me just put this. So I'll just run this guy
Oh,
some
would it
time.
just be the total? It wouldn't like add it. It wouldn't be the sum, maybe.
Not technically. It'll give an error because x isn't declared anywhere.
Oh, okay.
In a for loop, you need to declare the counter variable in the loop.
Oh yeah.
So I think there was an example of things later, but you need to put integer x equals 100, and then it'll get you the answer you're looking for, and that'll be it. So if we put like right, you'll be able to see it go. Actually, I should put there. So it'll go from 1 to 150 because that's less than or equal to this time. So the logic in that loop itself is okay, but the declaration of the variable was not. You could also say that total wasn't initialized, but it does say that total is 0. So you don't need to worry about that part, but you do need to say that the int part is needed to be in the loop when it's declared.
Okay.
Okay. And then we have the plus equal assignment operator. This is the same thing as these are the same thing. So any of the operators we talked about up here can all be rewritten in this form. So that's for everyone who doesn't know that, and it's a refresher for you as well. So that was that program, and I think, yeah, that was it. Let's see, what was this third example? Oh, it was the print one. So how do you convert from the for loop to the while loop and back? So for this for loop, what would it be?
The initialization you have to do first in the while loop.
So it's gonna be count 1, right? And then
And then it'll be while, and then the second expression.
Perfect. And then
I think the count, the incrementation.
yeah. Then what is there anything else I need to put in the loop?
Yeah, wait, let me see. Count is equal to 2.
Implementation. Right. And what's wrong with this code though? And it's wrong with these. I don't know what was wrong with this professor. But all of the examples have that error. Because if I run this, it's gonna throw an error.
Um,
It was
I'm
the
not
same
sure.
thing we had in the last two.
Is it the initialization? The int?
Yeah, an easy int.
Oh, and sum and count.
Yeah, both of them need one, right?
Okay.
And then it'll do its thing. we could just print. Cool. And then this while loop, I'm not going to code it, but just tell me what would happen. What would the for loop be?
Okay, so it'd be the int x equals 1, and then x less than equal to 20,
Mm-hmm.
and then count, or not plus plus x.
Mm-hmm. And then you put
And
the
then
condition inside.
Yeah, would it be the x modulus 5?
Where?
The if statement?
Yeah, so the if statement doesn't matter. You just put whatever this is inside the for loop.
Okay.
All you need to worry about is this part, this
Mhm.
part, and this part. Those are the keys for the for loop. Those are
Okay.
the three conditions. So the initialization, the condition, and then the incrementation.
Okay.
Initialization, condition, incrementation, right? So then the next
Mhm.
one is going to be the like an if statement, and then to convert this into a switch statement, what would you do?
I forgot what a switch looks like. I'm gonna look.
Okay, it's the one that goes like, so let me just do it. I'm not gonna do the whole thing because I don't want to copy all that, but basically it would be like switch, and then you have your number, which is basically the thing that you're comparing to everything. So in this case, it would be selection, right? Selection. Right? And then you're going to open a bracket, and you're going to put case 1, right? Colon. Whatever it is, print f times r. Then you finish that, and you do this, and then what you need at the end of every case is a break statement. That's important because if you don't include this, by the way, these two would be to the left, right? Then you do the second one, and then this, whatever, right? The break statement is important because if the variable satisfies more than one of these conditions, then it'll just keep going down the list and comparing all of them. Because usually what happens after you do the case statements is you do a whatever. Then you do like a default state, right? And then this is if there's nothing else, and this is what the very last else statement is going to be, right? So the break is important because if you don't include it, it'll just print this and the default. And that's the importance of this part. So the if statement already has like an automatic break installed in it, in the sense that if one of these conditions is like satisfied, it'll go to the end. But the case statement or the switch statement isn't in that case, or isn't like that. It'll go through and check against everything, which takes processor time. So a big like important thing is to make sure when you're transitioning from if things to the switch statements, you include the break at the end of each line. And when you're going backwards, you don't need to have the break, right? When you have, if you were given this and you need to go to this, you would first just see that this is what's going to be at the first part of the if statement. And then the case 1 is going to come down directly. This one argument is going to come down, and it's going to go from here, here, right? And then you're going to do whatever, this, and you can have your else if. And then the 2 comes from here and goes here, right? And then you do whatever, and then just finish this off, right? So that's how you transition from a switch to an if, and then from a series of ifs to the switch statement. Make sense?
Yep. What did you say again? If it matches 2 of the cases?
Basically, if you have a, like for example, if this is 2, you won't really have it. It won't really happen. But for more complex conditions, it might. But I really can't think of an example. I just know that someone told me that you need to worry about that. But the real thing you need to worry about is not triggering the default as well as whatever case you're satisfying.
Okay.
Yeah. Because usually this is not going to equal more than one of these. Unless your case statement is built weird. In that case, that's your fault. But that's what I was told. I haven't run into that issue though, so I wouldn't worry about it too much.
Okay.
All right, and then this one. This is a fun one. This is the last one we're gonna do for this part, and then we'll go through the assignment. So, what do you think this is gonna print? It's one of those nested loops, right?
Yeah. So it starts with the inner one, I think.
Let's start with the inner one.
Okay.
And this is a star or asterisk if you can't see from your screen.
Okay.
So the inner loop
start from 1, go to 4. Oh, would it just be like 4 asterisks?
Yeah, so that'll be each time the inner loop triggers, there'll be 4 asterisks. And then what happens?
And then the next row, we print 3, and then the next row 5.
No. So what it's going to do is it's going to go, this inner loop is going to trigger, right? It's going to go k equals 1, k equals 2, k equals 3, k equals 4. Okay? And then it's done, and it goes from here, it goes back out here, right? And it goes, well, technically you start at the top, okay? You're going to start at the very top, and you're going to go I equals 1, j equals 1, and then k equals 1, right? So it means you've finished this, and now you're going to go to this line. And what does this do? What does this line do?
Doesn't that make it like a new row?
Yeah, it makes a new line, right? So it enters 1, and now j is 2.
Oh, yeah. Okay, I remember.
Okay, so j is 2, and then it goes back into this and goes, oh, you're doing this k bullshit again, right? I guess we're going to do it again. 1, 2, 3, 4, right? And then it sees, oh, a new line. Let me do that real quick.
Oh, and then
and it goes up here. Now j is equal to 3, right? Then it goes, oh, we're doing this k thing again, right? So we're gonna go, okay, fine, 1, 2, 3, 4. Sounds good. And then it goes, oh, line, might as well, boom. And then you go, oh, j is now increased. Now j is 4, so we're done with j. Okay. Then we're gonna go to I, and now I is 2. Well, no, actually, j is equal to 4, so we end and we go to this next line here, and that's going to put another new line. So you're going to do another new line, and then you're going to go to the top. So now j or I is equal to 2 out of 5, right?
Mhm.
So I is equal to 2, j is back to 1, and now k is back to 1. So we're going to do 4k's again, right? Now
Mhm.
j is 2, right? We've done 4k's, we've done this line, and we're going to go back to j. So now j is going to output 4 more times, or k is going to output 4 more times. Trigger here, 1, 2, 3, 4, right? And now j is now 4. It breaks, it goes to this next line, adds a new line, right? Right, this part. And then this is going to have another new line for I, because we're still in the I is equal to 2 loop, right? So now we finish this. We're going to trigger the increment condition. Now I is 3. You say, oh, I is still less than or equal to 5. We're going to do it again. So eventually, it's going to do this pattern how many times?
If that was at 3, then 3 more times.
Yeah, 3 more times. So let's see. I just coded it up, right? And you see that it did this 1, 2, 3, 4, 5 times, right?
Okay.
Does that make more sense? That's how like you make patterns. You see what pattern is this is how many times a specific pattern is in a line. This is how many times the line is repeating, and this is how many times that overall pattern is repeating. So
okay.
this number is how many times the star is printed. This is how many lines are printed because each time there's 3 lines, 1, 2, 3. And then this is how many times the pattern itself is triggered, which is how many times these ones happen. So 1, 2, 3, 4, 5.
Okay, that makes more sense to look at it that way.
Okay, sounds good. And you can use that table thing I told you earlier, where you just be like, oh, you do this, now k is 5. We're gonna go back to j. We're gonna print those, and you can type a draw it. And once you draw it like 2 times, it should be pretty easy to extrapolate the pattern from that. Okay.
Okay.
So that was the review PowerPoint, and there's anything specific on this PowerPoint you want me to go through. Let me know because there's like 130 slides, and I don't have the breadth to go through all of them. So I'm gonna just go through the class activities you sent earlier.
Okay, that sounds good.
Yeah, these participation assignment ones. This assignment 4, not hard, but I did this one, and I could do this one later. But we got this guy. We're gonna go here. So the motion using implicit casting. Does that make sense to you? Can you try explaining that to me if you know it?
I know implicit is like automatically done like by the computer.
Mm-hmm.
Demotion is probably taking one type and then like making it a lower level to a different type.
Sounds good. So what would like an example of that be? Let me go back to the handy dandy online C compiler.
Mm-hmm. I remember her saying like promotion, like implicit promotion.
Mm-hmm.
So like the short automatically goes to int.
Yeah.
Stuff like that.
Let me go through like the most classic example, and that's like the double one. So doubles can include decimal points, right?
Mm-hmm.
So what is this gonna output?
If it's int, would it just be 10.
Yeah, it'll just be 10.
Okay.
It'll chop off whatever decimal part is and only look at this part, right? And so that's what the implicit demotion is, right? Because the computer did it internally. And it didn't really do anything. You just told it to assign it to a smaller container. So it's like putting a big plant in a smaller pot and having to like trim the roots to get it to fit properly.
Okay.
But using that same analogy, right? If we have int 10 and then we put these, right? It won't really work because you can't really go from a smaller thing to a bigger thing. It just kind of, wait, actually, no, this is because I was dumb.
Oh. Wouldn't that be explicit?
Do you remember what the printf for the double was supposed to be?
Nope.
I think it's f, right?
Oh, I see what you mean.
Yeah. So it does work. So it just puts the small plant in the bigger pot, and it has more space to expand now. And do you remember what like what these?
Oh yeah, like the precision.
Yeah, the precision. So 6 decimal places, you get 6 decimal places, right? Things like that. Okay. So that's like that example, right? That's that demotion with an example. And there's not really a promotion because it's just not, you can't really promote something from, the computer doesn't know what to fill in the gap. So just put 0. So that's like the motion part. All right. And then we're going to go to this guy. Do you remember what like the short circuiting thing was?
Yeah, like when if you have the first thing it knows is like false, then it won't check the rest of the body.
Yeah, that's basically it. Because you see x greater than y and z is greater than plus whatever. We don't worry about this. Like x is not greater than y, so it's just going to return false. So it's going to output 0. So let me just bring this over. Actually, I can just copy this.
Yeah, and then and they both have to be true, or both have to be.
Oh, this guy doesn't have a. Oh. He's right of the right type for some weird reason. So yeah. See, this is 0, so it just goes, okay, this guy's 0. This guy is just irrelevant. It would give the same result. Cool. No need to worry about that. Odd or even? What would the condition be?
I know you have to use modulus.
So let's just go through it. We have int num. It's integer, right? So we're going to int num, and then what's this going to be?
I was gonna say, doesn't the scanf need a and?
Perfect. Good call. Okay.
With num modulus 2. Oh, never mind. Oh yeah, modulus 2. I think equality. like
So-
equal 0.
Yeah, what?
If it's equal to 0. Then it would be even, I think.
And then else.
That's odd.
Okay, so I was gonna sneak in 2 errors, but you found the first one. What's the second one?
The bracket.
Where?
Wait. I think after if. Might be wrong. Because doesn't the yeah, doesn't the else have to be like included?
Wait, what? So what should I fix?
I would delete it.
Like that?
I think so. And then put it inside the if bracket.
This? I mean, so you take this guy, so this guy goes in here. By the way, that's not the error. The structure of this is fine.
Okay.
It was one of the questions in the review earlier.
Oh no.
There's your hint.
Oh, is it equality instead of assignment?
Yeah, so it's equal, right?
Oh, I thought I said that.
Bobby,
I
I
didn't
didn't.
catch it.
But yeah, so
It's
that's
okay.
that. And
Okay.
there we go, gonna do like a 5, it's odd, 4, even, and then cool. But yeah, that's that. Yeah, good catch on this guy, and then sorry if I misheard you if you talked about that earlier. But yeah, that's this.
Okay.
Yeah. Then this one is pretty simple, right? It's like the salary flowchart guy.
I think
So
we did
it's-
this one.
Yeah, I think we did this one together. This would be that. I don't think we need this part though. So this is the program for anyone watching the review and wants to pause and whatever. And I actually didn't write this properly because this is in C++ and it's supposed to be in C.
Yeah.
So
Different.
it's a little bit. So this one is going to be the printf. This guy, and then it's going to be f, and then we need the what type of variable, what should be in that bracket
Which one?
right here in these parentheses. Sorry.
Okay. Oh, pay rate.
And so you look at the variable, that's pay rate, and that's a double. So what does this
percent D.
percent D? No, that's for integers.
F.
Yeah.
Okay.
You can also use long float if it's going to be a really big number, but you can just use F.
Mhm. Okay.
Same thing
Percent.
here. Yeah.
You left the percentage out.
Indian. And I won't ask you about that one because you got it right last time. So that, yeah. Hours worked is an integer, so you can put percentage here. And I think that should be it, right? And I just fix these part. And this is going to be what?
Percent F again?
Yeah, because regular pay is a double. It's oh, that's interesting. Let's see. I have no idea what this means. So I got past here, and the hours worked is less than 40. And I got true. Else, you got your 40 times your regular pay rate, and your hours worked minus 40. Divided by 5 times pay rate, and then I should alpha. I am not sure what this is. Oh, that would probably do it.
Nice.
And then cool. And then this guy should get a new line, and it should get a new line, and yes. So and again, and that's 0. So that's not right. Hmm. Hmm. Okay, so it's setting to 0. Um. So hours worked 41. It should go into this low. Okay, so it is going into this part properly. I can just So it's setting to 0 for some reason. I have no clue why you are not working. Because this should be the multiplication operator, and that should be that. Do you have any ideas?
I checked what we did earlier, and I sent that, but I don't know. The one that I sent, it worked last time.
You sent it to me? Where was it?
In the chat.
Oh, in the chat. My bad. Here. Okay. Let's go here, and then
This one seems a lot simpler for some reason.
yeah, that's fine. I think I went too much into it. And we kind of just set the pay rate to equal to 7.
Yeah.
So, yeah, I think this is fine. I'm gonna just do that. Flow chart. Yeah, it really was worrying about the hours. So we didn't need to ask for what the pay rate was. I think I overcomplicated it. I don't know what broke though. Let me see. Yeah, no clue. I'm just gonna keep going. So I'll figure it out. I'll figure it out later. But that's it. So within the range of 1 through 5, I don't think we did this one together. So we're just gonna go to like this guy, and I'm just gonna do this and copy you, paste you, and you're in C++ again. That's rough. And let me just fix you then. Okay. So that should do its thing, and I don't need this part. So that's that very, very basic program. It's like the input validation one. The exercise I want you to do, though, is help me make this into a switch statement.
Okay, it'd be switch, and then number, I guess.
Switch none, right? That's what we're
Yeah.
going to, and then this guy, and what's this gonna be?
When you just like copy the if.
So you don't use if statements in switch statements. They're kind of built in.
Oh yeah, case. Okay, that's right.
So what am I gonna type now?
Would it be case 1?
Mm-hmm. And then
And then num equal 1?
no.
No.
You just need to put case 1. It'll automatically do the equal.
Oh.
Do you know what's supposed to be after this part though?
I forgot.
So it's gonna need a colon, right? And then you're gonna put whatever is gonna be in this if statement. So this part comes up here. And then what did I talk about need after every case earlier?
The break.
So break, and then is that it?
The semicolon.
Yes. Okay, and then remember these two should be indented, so it's a bit easier to read. And then what's the next line going to be?
It's the case 2 colon.
2 colon.
Printf. Yeah, same thing.
Well, I'll just
break.
copy it.
Yeah. And then at the end is the default. Yeah.
And then what do I need to add after every thing? So is this done?
Oh, the breaks.
Okay.
You need 3 more.
I won't add the break after the number 5, so you can see what I was talking about earlier.
It'll print that one as well, right?
Yeah, so if I put 5, it'll print this part and it'll
You
print
enter.
it.
Yeah. Okay.
Well, you don't need a break after the default. Cool. Sounds good. And then we're gonna go to number 6. And that one is gonna be class average on the quiz. Use while loop. So I, again, wrote this in C++, which is dumb, but it's okay. We'll fix it. And then this is going to be this part is going to be here. And then and Okay. So what is the missing code that I need to put in here? I just kind of deleted stuff at random. So what needs to be added back?
Do you need a scan F after that printf?
This one?
The next one?
This one? Yeah.
Scan F. Percent D.
Mm-hmm.
And then and grade.
Is that it?
Okay.
Oh, it says use while loop, and I used a for loop. Whoops.
Oh.
So okay, how do I actually? I'll fix this, and then we can convert. So when you gave me grades, you need to give me like the array. Because grades is an array, right? So you need to tell me which part of the array you're going to input to. So you're going to start at 0, and then, well, actually, 1, 2, 3, 4, 5, 6, 7, 10. Yeah. Because the array starts at 0, and you're going to start, and you put the 0 number. Sorry. The reason you have I equals 0 is because the array starts at number 0, right? Like the index 0. And so you're going to put the grade of the student into index 0 here, right? And then you're also going to add the total. Actually, you're going to need to. Actually, you don't need to do that. Actually, you can just put from grades I into the total, right? But this isn't going to just give me equal, it's going to be a plus equal. So every time the loop triggers, you're going to add total here. Sound good?
Yeah.
And then this part, I don't think we need to worry about. I think you can just put. I don't need to cast anything. Divide by number of students and average, and then that should be it. And then, so what does this average need to, like, what does the print statement need to be here?
I am not sure.
It needs to, because we're outputting average, right?
Mm-hmm.
So we need to give it a little percent F, and then
Okay.
average.
Okay.
So theoretically this should work. It does not, because this doesn't have a semicolon. By the way, this is going to be integrated with student. To make it a bit easier on the user, I actually deleted this part, but you're going to put percent %d and then I. That way, whenever you run it, and this has the student 0. Actually, you want to do I plus 1 here, because technically the array thinks it's 1, but you need to do I plus 1 in this location. So student 1 is going to be, it's real formatting things. Student 1 is going to get a 15. This guy's going to get 56. Okay? And if I wanted to decrease the amount of things and I only want 2 decimal points, I would do that here, right? But it wants it as a while loop and not a for loop, right? Hello? Oh my god, she fell
Sorry, I forgot I was muted.
asleep. You're good. So how do I turn this into a while loop? I'll start it here.
Okay, so it needs the initialization first.
Okay, so what's it gonna be?
Like all the int total equals 0, int grades.
I don't need to worry about these parts. This part can stay. I'm just trying to finish this part. Yeah.
Okay.
So if
So
I
yeah,
equals
int.
0, right? And then
Yeah, I. And then the second statement, I less than number of students. And then the incrementation.
So how does this all work together to make a while loop?
And
You have this guy, and we have this guy. So you've extracted the useful bits out of this first statement, right?
Mm-hmm.
So now how do make a while loop from these three things?
Hint.
It should be pretty simple, but remember this slide?
Right, yeah.
Okay, there's your hint. Now go.
So while would be the while parentheses.
While would go here?
Yes, second. And then that second statement would go in the parentheses. That one.
Okay. What's going in here?
Oh, the if statement.
Yeah, whatever's in the for loop is going to go here.
Would that be if? Or not?
And then where's this guy going?
At the end, right?
Cool. So that's that, and that's how you would use it with a while loop. And so that replaces this guy. And then it goes here. Okay.
Okay.
All right. So then we got this one is how to it's a switch statement again, right?
Mm-hmm.
Do you want me to go through this one? You want me to go through this one?
I think we did that in class, and yeah, it's fine.
Sounds good. And then this one is a bit funnier.
Mm-hmm.
This one's a bit more technical, so we'll just go through this. I'll show whoever's watching this later what the C++ look like. Basically, ignore these and make it print statements. It would just be the case one and break, and you would case whatever break, and then you have the default, which is the invalid input. And you would read into the num, which has the and sign, and this is going to be the printf. That's pretty much all the changes I would make if I was trying to translate this into C. Yeah, and then so how this would work is you would say num is equal 1, you do this and break. Otherwise, check the next condition. If it's 2, you break, and if it's not any of 1 to 10, you say invalid input. Okay, so that's that. Also, you would use Studio H instead of IOStream here, but that's a different story. We'll go into this last problem, this one. So what variables should I initialize up here? What do you think I should need?
Would it not be all of them?
Yeah, so what would all of them be?
So a amount should be, oh, like at the end. Okay, never mind.
So what type of variable should I make amount?
What do you mean, like percent D or percent?
So like what should I type here? When I'm initializing the variable at the very beginning. I can just type amount, principal, annual, years, right? But that won't really, these are just variable names, right? These are all going to be equal to 0.
Yeah.
What do I need to add?
Well, A uses like the formula.
Way
to get
before.
it.
Like, this is like week 1 things you need to worry about right now. What should I put before amount here?
Before it, like int.
Is it an int? Okay, let's try it with int. What should principal be?
That one's just 1,000, just number. So isn't that int?
Yeah, that's going to be right. And also, these all need semicolons. What type? What's annual going to be? Technically, this is a rate. This is not a rate.
Oh, rate. Okay.
What's this going to be?
Is that, what's a percent? Is it float?
Yeah. Okay, years.
And it's also 5. Oh,
yeah, sorry, what
that
would
one's
rate be?
5. Oh, 0.05.
Oh, and then years is going to be a
int. And it's 10.
Cool. All right, we're going to go here. Let's go end of each year for 10 years. So I'm going to use a for loop this time, okay?
Okay.
Actually, I'm going to use a while loop, and you're going to tell me how to turn it into a for loop after it finishes. So I'm going to figure out, let's do int year equals 1 while year is less than the years, and here, and then I'm going to need to calculate amount and print it. Those are plus signs. Yeah. And then we're going to have our good old trusty return 0. Okay. So what should I put here? You are muted. If that's
Oh, oops. Would that be the formula?
yeah. So what's the formula going to be? How do I put that into this?
Amount equals principal parentheses 1 plus rate. Oh wait, or I could put 1,000. Or okay, I'll just say 1 plus rate. And then can you do the caret and see? I don't know. And then
Right, and then what
years,
is
yeah.
percent sign going to mean to be here?
And year.
I put years, and I need to put. I'm going to put amount in year 1 is amount. So it's going to be year amount. And amount is right.
Percent F, I guess. So it'd be a bigger number.
Not really, because you see amount here is an int.
Yeah.
So you just put D.
Percent D. Okay.
Okay. Did I not? So you can't do this. You can't, because it thinks that this is a function.
Okay.
Like it doesn't understand that being next to each other is a multiplication. So how do we fix that?
Oh, you have to do the
Multiplication,
asterisks.
right? Yeah.
Yeah.
Okay. And we're gonna put this again.
Hello?
So invalid operands, this guy.
Oh yeah, that's this.
So
Okay.
you can't use this guy. Did you learn about the function to do this?
I don't remember. Is there like a math
Yeah.
page? Yeah. Would you put power?
This math. Yeah, that's the function. Do you
Okay.
remember the syntax for it?
No.
Okay.
I don't.
We're gonna put pow, right?
Mhm.
And then it's gonna be the first part is gonna be the base, and the second part is gonna be the exponent.
Okay.
Make sense?
Mhm.
All right. So we'll run this guy, and I should probably put a
New line.
okay. And so it seems a little broken.
Mhm.
Why?
Mm,
So when I do
is
this
it because
calculation, right? When I do this calculation of 1,000 times, let's just see what it's supposed to be for year 2. Okay. We'll do 1,000 times 1.05, right? To 1. This would be 1001.05. Okay?
Mhm.
And then that goes into amount. What do you think the issue is with that?
Because amount starts at 0 or
No, because it's an int, right?
an int.
It's an int, and this has a
Mhm.
decimal. So it should be double. And also this principal should also be a double to make everything easier.
Okay.
And when you initialize it, you want to put it as 0.0, just to make it, it's a superposition, it doesn't really matter. But this is going to be, it's to help with like people who are checking over it to be like, oh, for sure, this is double.
Uh-huh.
And so I believe that should fix it. It does not, because I'm dumb. And let's see. Mm. Nope. Mm. Oh, year. That broke it more. Okay. Let's see. Oh, because when we made them doubles, right? We didn't change this. So this percent F. Ask me percent
Oh,
F. And I switched these two somehow, actually. Why are you the correct? Okay, I give up trying to code this by myself. Let's just do this guy. In the end. So that was the code I wrote before, and I'm not sure what was wrong with it, but this wasn't working. So let's see. Principal, year. I mean, I just put this here, so that should be fine. To I can float, I guess. Actually, this is also double, but they should be the same thing. And then that, and then year one, year less than equal to years, year plus plus at the right end, and then amount equals principal times PAL, 1 plus rate, common year, and print year amount. So year is actually a percent D, and amount is F. That might have been it. Okay, cool. Nice. Yeah, that's it. Cool.
yippee.
Yeah, that should be it. So that's all I had for this like exam review. Is there anything else you wanted me to do or cover?
Okay, did you still want me to convert it to a 4?
Oh yeah. My bad. Was there anything else I was given? Was it assignment?
I don't think so.
Bless you, whoever that was.
Not me.
Okay. Yeah. Let's make this guy into a for loop.
Okay. So,
Which you saw before, but yeah.
is it start with 4 year equals 1, and then yeah, would be year less than equal to years, and then year plus plus,
Okay,
and then the
let's
body
make
would be the same.
right.
Yeah.
Okay. So this is gonna throw an. Actually, no, it's not. Yeah, it is. It's gonna throw an error. Remember, you always gotta initialize your counter
Oh
variable.
yeah.
Poor, your poor teacher and you made the same mistake. Right? So always, your counter variable should have an int or a double or a float or whatever here. Okay?
Mhm.
And it'll output the same thing.
Okay.
Okay? And if you wanted to decrease the amount of the floats to make it look a little cleaner, dollars and
Mhm.
cents. And then
Okay.
dollar sign. And yeah,
Okay.
so those are all the examples. I think that's it. Yeah, cool. Is there anything else you wanted me to cover about like anything in general? Anything from one of the PowerPoints?
No, not that I can think of.
Okay. Because that was the PowerPoint assignment, exam 2. Oh, we didn't go through the assignment 4. Um, let's see.
Oh dang, I just checked if she said our quizzes were like made available to look at again, but I just checked and they're not, so never mind.
Okay.
Yeah. Oh well.
I'm gonna chat GPT these and we'll just go through these together.
Okay. Right now.
Yeah. I mean, it should be fine.
Oh what?
Okay, so we're just gonna go through here. Right. So assignment 1 is the for loops to print the whatevers. It's just a series, it's like a pretty monotonous thing, whatever. All right, it's gonna print A, and it's gonna print like 1 through 7 for this first one. Does that make sense? Because the pattern is just increasing by 1, so that's what this I plus plus is. The year is starting at 23 and it's ending at 23, and it's increasing by 5 each time, so that's that, right? This one starting at 20 and leaving at -10, and it's decreasing by 6, right?
Yep.
This guy is going to start at 19 and at 51 increase by 8. And this is going to count down by 2. So that's it for this one.
Gotcha.
Yeah. So this is what it said for this one. The mod equal 40. This one's 3. Right. How it does it is it scans and then it'll actually I don't know why is it. Oh, for the input validation. Okay, got you. So for example, when I do this and I give it -10, it'll just keep saying, what is the speed in miles per hour? Because while the speed is less than 0, it'll stay in the loop. But once the speed is more than 0, it exits the loop, right?
Right.
And then the same thing for the time. If the time is less than 1, then it'll stay in the loop for time. Otherwise, it'll leave and it'll go into this section of the code. Okay? So if I give it 10, and it's going to go how many hours, and I give it 0.5, it'll break itself. I have no idea why I did that. Yeah, no clue. Anyways, that was the theory. I'm not gonna spend much time figuring out how it happened. So 10 and then 1. I think it was just a fraction that gave it. Oh, because I put in a float value, and the float value was supposed to put into the decimal, and it kind of broke it. So I assume if I put -1.5, it'll kill itself. And it should do the same thing if I put it 10.5. Tell you what that was. 10.5. And then yeah, it's dead. So this would probably be best if this was a float. Just for program security sake. Okay, nice. I will give up on that. So how this works is that it'll print the like the hour, and then it'll print the hour times the hour times the speed, and then I'll give it the distance traveled. So using it normally, this is broken because it was F. So it'll do the hour, and then it'll do 10 times the hour, which is 2. So 10 times 2, 10 times 3, 10 times 4. So it'll do 2, and then 10 times 2 here. So that's that. I think this one's pretty simple. It was just the input validation, which was interesting. I wouldn't have done this. I would have done an if statement and a while loop, but this also works. Okay, assignment 3. Let's go here. And that was multiple integer numbers and then use input. Largest and smallest number entered. Okay. So I'm just gonna put in. Cool. At least this one works properly. So it'll scan in a number, and then it will just keep going until while the number is less than or equal to 99. But each time the loop is triggering, it is reassigning the max and the min numbers here. So how it would work is that when I input 10, right, 10 is not equal to 99, and max is this value, and then min is this value, right? So 10 is greater than the max value for sure. So max is 10, and then 10 is also less than the min value. So now min is 10 too. It's inputting 20, and 20 is not equal to 99. It's going to go, are you bigger than my max value, which is 10? So 20 is bigger than 10. Now the max is 20, and the min is going to be still 10 because 20 isn't less than 10, right? It's going to keep doing that. And then what happened here was it's not negative 10. It was like, oh, negative 10 is less than the min, so now I'm the min. And then I saw this number. I was like, oh, you're a very big number. You're now the max. And so it just kept those values and then it printed them here.
Wouldn't it make more sense if like the max and min were switched?
So you're saying if I made the max this and the min this?
Well, but then the if statements would have to be switched too. I was just thinking because like max being negative.
The reason it
doesn't.
was like this is just to make sure that whatever number was input, it'll assign it normally. Because if the max was positive 999, then yeah, this would need to be switched, and then it would be the min. So
Okay, but it doesn't really matter what they're called anyway.
not really. It's just as long as the code output you tell it the right numbers, then the right variables to output, then it'll be fine.
Okay, gotcha.
Okay. And so yeah, I was originally gonna say an array would be fine, but then I saw this part and I was like, oh, okay, sounds good. So she wanted it to happen with the less than and then greater than and then dynamically updating each time something's entered. So yeah, let's go into the sales bar one. 1,000, 100, 200, 300, 400, boom. Yeah, it's not that difficult because you create the array. It's got 5 numbers in it, and then you just count down, or sorry, you count up but you have to start at 0 because the array, because this goes back to the example we had earlier, for the grades, I believe, for the students, it's going to be I plus 1 instead of just I. So for store 1 through 5, it's going from array position 0 to 4. But just since you want to go from 1 to 5, you add 1 for the display, right? And so all of those go into the sales value. And then it's going to print store number I plus 1 again because you have everything started at 0, but you're going for store 1. And you divide by 100, and each time that j is less than the maximum, you're going to print the star. So for example, we have 1,000 here, so we go 1,000 divided by 100, j is less than 10, so it'll go from 0 until 10. So each time it triggers, it'll go to 1. This looks like a minus minus, but it's a plus plus, so j is incrementing, and then once j is 10, this will stop. If this was 1, you would need to go less than or equal to, but if it's not, so you just put, so if this is 1, you do less than or equal to, but since it's not, you can just keep it at 0, and then you put less than here. And then you put a new line for a new store. So that's that explanation. It's a pretty simple, fun program. Factorial, whatever. Factorials from 1 to 5. It just goes when you do factorial the function, it just is it's a simplification of basically what it does is it returns whatever it is here. So the factorial function it just does like a while loop. And it just does like j like that. And so I assume you know what a factorial is, so it just goes from 1, 2, 3, 4, 5, 6, and it multiplies the previous one from that. So 1 times 1, 2 times 2, 3 times 2 times 1, 4 times 3 times 2 times 1, and this. And so the reason like 20 would be like impossible is that like 20 factorial is like huge, right? And that can't be stored in an int or a double value. And so that's what it means by it would overflow. It literally could not be contained in one of the data types. So yeah, sorry, this is the factorial one, factorial function. Here. Cool. I missed that, which means I'm tired and I need a nap, but we're almost done, so I'm just going to keep going. Assignment 6 is this one. Oop. Oh, this is like a conversion table. Fun. 1 through 256, and it just does that. It takes advantage of those, what's it called, the variable or the format string numbers. So you have the decimal, the decimal, octal, binary, and then the hexadecimal. And we got our decimal, our binary, and then our octal and our hexadecimal, and then, and it just puts them in this format. It's really simple. It would be tricky if you didn't know about the variable types. And this is all a type of implicit conversion. Well, no, that's not the right word. It's just putting them into different data types. So it's not even implicit conversion. It's just converting it automatically. Cool. And then assignment 7 is going to do this pattern thing, which is really cool. So for pattern 1, it's starting at 1, and then you're going until, I believe this is 5? No clue. But it's going to print these guys. I don't know if it's actually going to do it right. It is. Cool. This actually needs to be printed a lot more, but for proof of concept, it is about the same. It will print one of these, and then it'll increment, and it'll print 2, and it'll increment, and then print 3. So for each I, it'll increment. You can see that the assignment is the j is less than or equal to I, and so when I is equal to 1, j is only going to print once. When I is equal to 2, when the loop comes back, it's going to print 2 times. That's to 3, it goes to 4, and then it's going to go print 4 times. So 1, 2, 3, 4, 5. 4, 5 times, and then that's it. And this is going to do the same thing, but it's going to decrease I instead of increasing I, and it's going to start at the max value instead of capping out at the max value. So it's the pattern in opposite directions. I believe this is 10 instead of 5. So if we wanted it to look similar, we would just change these two values, and then it would go until 10 and come down from 10. So yeah, I think that's it for this assignment. I just blitzed through them all, but that should be it. If anyone's looking through the review, that's how all of the assignments would be done. And I think I went through an explanation of all of them. So yeah, I am respectfully probably not gonna go through all of the slides in this 130 slide PowerPoint, but I think we went through most of the high level concepts in this.
I do have like one slide that I had a question on. It was like the very last one because she kind of like briefly went through it.
Do you know the number?
Wait, go up. Actually, let me just look.
Yeah.
But it's like towards the very end. Okay, it's like the end of file one. Oh, 124.
124? Okay.
Yeah, this one. Not really sure what that means.
Okay. So which part specifically are you confused about? Like this part?
Yeah, like, I don't know, I'm not sure what it would output, I guess, and also what EOF does.
So this is like they should have gone through EOF before. Yeah. I think they didn't go through it. Basically, EOF stands for end of file. And so what this would do is, if we're going up here, right, it's going to get char from this, from a file. And then if it's not the end of file character, then it's going to keep going, right? So these are all the letters. And so we're going to go here. So it's going to run this program, and then it's going to, but usually EOF is used for like file reads. Here they use it a bit differently. It's used as like an escape input. Basically, in that earlier example, I don't know if it was here. I think it might have been. Yeah, it was this number 3. Um, when we said when num is equal to 99, right? That's when we stop assigning things.
Mhm.
It's the same thing here where it goes, oh, if the EOF is in this case caret z, I believe, from this, right? EOZ,
Mhm.
z. And so basically what that means is while this is not that character, it's going to enter into the loop and do its thing. Right? It's going to do
Oh,
the
okay.
switch thing. And so it'll increase A if it's one of these two, increase B if it's one of these two. Also, this is that strategic use of break I mentioned earlier. So it'll look at this one or this one, and then it'll trigger this and break. Otherwise, it'll go here and break. Does that make sense? So this
Like
is
it
a
can look
time you
at
don't
two
put
different
break.
cases.
You don't put break. You don't need to put break after every case.
Mm-hmm.
How it would work is it checks if it's A or uppercase or lowercase a, it increases A and breaks. Otherwise, it'll check against both of these and then increase and break. If you had a break after each one, you would have to put this A count between the lines. So theoretically, you could put case A plus A count break, case lowercase A count break. But this lets you check against both the uppercase and the lowercase without having to duplicate this code.
Okay.
So that's that. And yeah, that's it. So that's what this is meaning. To this is part of this what it meant earlier of like how it'll ignore those grades or these characters. So if you were running this program and you input these things, then it would still just put in the next line. I think that's everything from these sets of slides.
Mm-hmm.
And yeah, it stores it. It puts this car value into a grade, and that grade is then used to compare against all the different case conditions. So you have grade equal A, yes, increase A count break. Otherwise, you equal B, check against all of those things. If it's none of those, then it's just gonna go incorrect letter grade and then enter a new one, which is what this statement was here. And then that's it. So we do that there. Yeah, that makes sense.
Yay. Yes.
Okay, sounds good. Was there anything else in this in the slide deck?
I don't know if I saw it in the PowerPoint, but like arrays. It might have been the last PowerPoint, honestly, but I looked at my notes. I don't have anything on arrays.
Oh, okay. That might be a slight issue. Let me go through that because I assumed you were knowing about it when I was talking about it earlier.
I was gonna like, oh.
Let me start here. So we have this one, which is what, assignment 4. I'll just go through this one. So when you have an array, right? It looks like actually. Let me just see if I can go like array. So it looks like this. So it's like, remember the mailbox analogy I used?
Yes.
Kind of, okay. So basically think of this as like a neighborhood, and these are the addresses, right? And these are called the
Mhm.
indexes. In computer science terms, they're called indexes, right? And so you always start at 0 because computers like starting at 0. And each of these mailboxes has this is the number of the mailbox, and these are the contents of the mailbox. Does that make sense?
Mhm.
So at address 0, there's a 41 inside. At address 1, there's a 97. Address 2, there's a 91, so on and so forth, right?
Right.
So up here, when we saw sales 5, right? This is saying you're going to start a little thing and you're going to go from sales 0, right?
Mm-hmm.
This basically means at mailbox 0, you're going to put 1, right?
Okay.
And sales 5, there's not going to be, that means there are 5 total mailboxes, which means the highest number you can put is 4. Does that make sense?
Yeah.
Okay. So that's how you would assign all these, right? So how this program is working is that it is every time you go at store 1, 2, 3, 4, 5, whatever, you're putting it into that corresponding thing, right? So if sales for store 1 is 15, this is actually going into mailbox 0.
Right.
Just because it's giving you a false thing, it's doing I plus 1, but this is actually at 0. Okay? So sales 0 equals 15. And then it's going to keep doing that, right? So we just go to and what it did is it stored all these values, right? And now it's going to go look at all of these and go sales I. So this is how you refer to a specific mailbox. If I want to refer to sales 0, I would just put on sales street. I'm building on the analogy, right? Because you could have multiple arrays. You could have right? And so this is another street with 19 spaces on it, or 19 mailboxes on it, right? And so if you want to refer to the first element, you have to refer to numbers 0, because that's technically the first. You don't refer to numbers 1. That's the second one. Does that make sense?
Mm-hmm.
And so
Yeah.
what's the highest address in this array, numbers 19?
It'd be 18.
Yes, 18, because 19, there's 19 spaces, but there's only 18 is the highest number you can refer to, right? So that's basically arrays. They're very simple, but they're really useful.
Okay.
And so I hope that gives you like a better understanding of like how this specifically works. It stores all these in different numbers. And so these are all stored in the array, and then it'll go through and do this. So one thing you can do to print the values of an array is you have to use a loop. Do you get why? We don't have to use loop, but loop is the best way. Because if I wanted to print the value of whatever is in the sales thing, right?
Mm-hmm.
There's a way to return with the size of an array, but I don't know it in C. So I'm gonna just say 5. So it'll be like this, right? I'm gonna go through here, and then I'm just gonna print F, right? Print F equals at index %d is %d. And here I'm gonna put I and sales I. Does that make sense?
Yeah.
It does not make sense to the computer because I forgot the semicolon. So I don't have a new line, but it's basically going to iterate through the array and then go through it. So does that make sense?
Mhm.
So that's how you're going to print through an array, because you're going to have to go from the 0 to the biggest number and then go here. So if I put less than or equal to 5, right, it's going to give me an error. Because there is no index at 5, it's just going to give me a junk number.
Okay.
This is, do you remember how I mentioned that memory is like this? This is basically saying, oh, the array is a bunch of variables that are just very much next to each other, right? It's like when I'm declaring this, I'm declaring 5 different int variables that all happen to live next to each other in memory.
Mhm.
And so when I look for index 5, it's going, oh, you're going to the next guy over from 4. That's just this random number that was put in there by another program. This isn't part of this guy's like a neighborhood. This is like the next neighborhood over.
Okay.
That's why that's like that. That's why I gave this
So it's
random.
just whatever was in the memory.
Yeah, whatever's in memory at that random address outside of the array.
Okay.
And that would change based on the computer you're running it on, the program you're running it with, whatever. So that's why that variable is there. So yeah, hope that helps with arrays.
Yeah.
And what they are. Yeah. Is there anything else with whatever for the exam tomorrow?
No, those were my last questions.
Okay, perfect. Sounds good. I'll